Hello everyone. So today's project we are looking at a 1957 ILG Model 213. This fan is a recent acquisition of mine, and this is now the first and only ILG Model 213 that I currently have in my collection. Uh, this fan is in pretty good cosmetic shape. It has most of its all original paint is all intact, and it's in pretty clean condition. It's not badly oxidized or anything. But unfortunately, there's one problem with this fan, and that is the motor is burned out. I knew that going into this, so it's not like I expected it to work and then got it and it was burned. No, I knew when I bought this fan that the motor was burned on it. But I looked at that as a fun little challenge. So, today we're going to be digging into this and seeing what we've got. So, just a general look around, you can kind of see the condition of the blades. There's a little bit of paint missing here and there, but other than that, it's in pretty good shape. Bullet cover, of course, the ILG logo is practically all gone. It's like flaked off, but the rest of the paint is in good shape. So I don't know. I guess to me it almost looks like that logo wasn't very well adhered to the paint. So you can also see remnants of the patent sticker, and the later ILGs had the little rotation sticker stamped on the blade, even though it's pretty obvious which way these turn. But I guess to make sure there's no confusion, they used to put these little stickers on them. So anyways, let's dive into this thing and see what we've got. So, take the bullet cover off. And voila. So, somebody has definitely been in here. These wires are all wrapped with heat shrink tubing, and let's see, this is a 6-lead motor. So what that means is this motor is actually reversible. It may not say it on here, but there's 3 different windings in this motor. You have a start winding that goes to your capacitor, and then there's 2 run windings, and they can either be put in series or parallel with each other to give you either a different voltage combination or a different speed. So, having all 6 leads means that each of the ends of those 3 windings are exposed out here. Which, I mean, it's not a bad thing. I mean, it gives you flexibility, I guess, but in reality, you would really never need one of these to run in reverse. They're not really designed to run in reverse. This blade design does not really work very well in reverse. It's made to spin in one direction. But anyway, that is something to note on here. The original run capacitor is a 10 microfarad, and it's rated 330 volts AC. I definitely will not be reusing that cap, whether it's good or bad. Most likely, I'm guessing it's probably bad, because that tends to be what kills these motors anyway, is the cap fails, and then it overheats the start winding, and it all cooks from there. So, let's take a further look into this. And I'm going to take the motor out of the frame, and I'm going to take the blade off. Alright, so I had to do a little bit of maneuvering here, but the blade is loose and it is off the shaft. I used an 8-point socket, works really nicely for these square head set screws or grub screws. Obviously, an adjustable wrench or an open-end wrench will work just as well. This one was a 5/16. So, I'm going to just slip the blade out. Now, whoops. Alright. Sorry about that. Not all of these ILGs you're able to do that. I found most of the smaller sizes you can, but for whatever reason, the 183 in particular, you have to take the blade and the motor, like you have to slide the motor out and take it off the blade at the same time in order to get the blade out. You can't take it off without moving the motor like I just did with this one. So anyway, there is the front side of the blades, also in pretty good shape. So now we will take a look at removing the motor. So what I'm going to do is I'm going to put a block under here, a couple blocks of wood under the shaft so that it doesn't just completely fall out on me. And this is we use a 1/2-inch nut driver, and hopefully they will loosen up. Usually once you get one of them really loose, the rest come out fairly easily. Bolt here. Now, to actually get this motor up and out of the frame. So here's the frame, and it actually has a little bit of like a black, almost like a soot on the inside here. So I guess this thing definitely got a little warm. Of course, with all these aluminum framed ILGs, just this frame by itself is actually quite light. So now we'll get these out of the way. And we'll move the bullet cover. And now we can look at this motor. Alright, so with the motor removed from the fan, we can get a better look at things. Just to read off some of the specs on this, this is a motor number 19-21-012B. It's a frame 19. And this one in particular is rated just for 115 volts. It's 1/5 horsepower. 2.8 amps, 60 cycles, and this one's rated as a 2-speed, 1140 or 855 RPM. It is a continuous duty motor, and of course it is single phase, has a 50 degrees Celsius temperature rise, and it is code E. So this is an ILG, Electric Ventilating Company motor. They made their own motors. They loved that. They would advertise that one nameplate manufacturing. Everything was made by them. So in most cases, they did have some fans that they would they would actually put like GE motors in. There's some little twist here and there to that, but particularly with their older equipment, it would strictly be all ILG made. So it's pretty cool. But anyways, let's see what we have in here. So we have the capacitor. These capacitors, typically there's a hole in the casting that the wires go through. They go inside and they actually just run straight down, and a lot of times they'll come right back out in the same spot. Now there's only 6 leads coming out here, so I have a feeling that the leads to the capacitor are probably cut, but we'll find out shortly. This would be a 3/8. Nope, we've got a 3/8 nut driver. Usually once you crack them loose, unless the fan is really heavily corroded, These usually come apart really easily. So I believe these are a 1024 thread. Okay, so we've got our draw bolts removed. Now the end bells should come off. Let's see. Okay, you never know how they're going to come apart. This one, the rotor came out with the front end bell. We have a wave washer or spring washer put in for preload on the bearings, and these bearings are 6203. This rotor is the type that has the cast in aluminum cooling fins, and it is a 9087C is the rotor type. I noticed they have different numbers. Some of these will say 9087A. I've seen some that say C. I'm trying to think if I've seen any that say B, but I guess maybe it has to do with slight differences in how the rotor is constructed. But anyways, we'll put this aside for now. Because what we really want to get into is this winding. So, let's see what we have here. I know this is in bad shape, so. Okay. Yeah, it's definitely crusty. This is the little insulating bushing. Sometimes these break, but thankfully this one's all intact, so I'm just going to put that right back in. As you can see here, the wires for the capacitor they would have ran through and out through this hole, so they're just in there. I will be removing that and replacing it with a modern capacitor. So here we have the stator in its lovely burned out condition. Now fortunately, since I've done quite a few of these, I know how these windings are configured, so I'm really not too concerned with trying to map out the winding on this. My biggest concern right now is just knowing how many turns for the start and the run windings, and also what gauge the wire is. So I'm going to have to start to cut this apart in order to find all that out. But before we get to that, I can actually kind of pry some of these out a little bit and just take some measurements and just see. It looks like most of the varnish is actually completely just burned off of these windings. Like there's nothing holding this together. They're all totally loose. You should not be able to do that with a good motor. For one, there would be some kind of lacing that would hold all this together in addition to the varnish, but there's nothing here. These windings are all just loose, which means they'll probably come out really easily. But yeah, this poor motor really got cooked. So let's see what we can come up with.